Hey everyone, welcome to Data Umbrella's webinar. I'm going to do a brief introduction and then hand over the microphone to Amy. And if you have any questions, ask along the way, and we'll get them answered when it's a good time. This is being recorded. Data Umbrella is a community for underrepresented persons in data science, and we are a nonprofit organization. This is our team. I'm out of New York. Beryl is out of Nairobi, Kenya. Christina is out of Brooklyn, New York. And Sangam is out of India. And these are the people that make it happen behind the scenes. We have a code of conduct, and we thank you for helping to make this a welcoming, friendly community for all. There are various ways to support Data Umbrella. The first and foremost is to follow our code of conduct. If you can share our events with other people, that would be greatly appreciated. And we have some projects in our GitHub repo if you are interested in contributing. One of those projects is timestamps. We do timestamps for our videos. We have a website, which is all open source. We have a PyMC Sprint website. Our blog is all open source, and as well in data events board. If you're so inclined, if you want to support Data Umbrella with a donation, we are an open collective as Data Umbrella. If you want to subscribe to our YouTube channel, I'll share the link in the chat in a bit. We have 3,700 subscribers, and we have a really we have a rich library of events in data science, Python, R stats, and open source. One of our playlists is career advice. Others include data visualization, contributing to open source, a special series for scikit-learn, PyMC, and NumPy. We also have a monthly newsletter, which I'll share in the chat. It goes out the first of the month. With our upcoming events, recent events, and news, all things data science and open source. This is, if you want to scan the QR code, these are the links in the platforms where we are the most active. So Meetup is the place to find out about upcoming events, and YouTube is the place to find out recordings of our recent events. We use Big Marker for this webinar, and it has live captioning. So at the very top, if you see the letter CC, closed captioning, you can get a live transcript as it's going. We also have an online suggestion box, and I'll share the link in chat. So if you have any suggestions for future event topics, if you have any feedback on this event, if you want to communicate any technical issues that you encountered, if you have any other feedback, and if you're interested in speaking at a Data Umbrella event, let us know. Our next event is on September 10th. It is Best Practices for Creating a Data Science Team, and we haven't posted it on Meetup yet, but it will be there soon. Today's talk is Why Knowledge Graphs Are Hot Right Now. Our speaker is Amy Hodler, who is a graph advisor and consultant. Amy has decades of commercial experience, including with Neo4j and relational AI. She promotes graph technology in various industries and has founded the GraphGeeks community to foster cross-discipline interaction. Amy is highlighted as a distinguished speaker by G Research and has authored, contributed to several books, including Graph Algorithms. You can find Amy on LinkedIn, and you can also find her on a Discord server for GraphGeeks. And with that, I will hand over the microphone and screen share to Amy.
Awesome. Thank you, Reshma, and thank you everybody who has joined us. It's very exciting. I am sharing screen now. So very happy to be here, and I will pause and take questions as well. As Reshma said, I have been in the graph space for a while, in the tech space a little longer, graph space for a little over 10 years, in various different companies, including Neo4j, Cray. I have founded recently a community called GraphGeeks, and you can find us online. I've also authored several books and love to speak on the topic, so I really appreciate the chance to speak to all of you here. We're going to very quickly go over the basics of knowledge graphs and use cases. I'll pause for some questions. Then we'll talk about stats of the knowledge graph market, why it's hot, and what's coming next, which is always fun. And so I'll pause periodically, but if you don't need to wait, if you have questions, go ahead and put them in. So if you're not already familiar with graphs and knowledge graphs, you might say, well, why are people so excited about it, and what's it used, like what industry is it used for? And that's almost an impossible question because knowledge graphs are used across many industries, everything from communications and telco to supply chain, logistics, social understanding, financial services, banking, security, cybersecurity, so health as well. You see it a lot for drug discovery. So knowledge graphs are used throughout different industries. And at the very basic level, you're talking about how to leverage and make use of connections and uncover patterns. So, so looking at those kind of two areas are kind of the magic of what graphs in general do, and of course, knowledge graphs in particular. Now, to the basics on what the heck is a graph, it's basically any model of nodes and relationships. Nodes, I think of, those are always circles for some reason. Those I think of nouns, and relationships often you can think of as verbs. So this is a really simple graph. This counts as a graph. John likes ice cream. Pretty simple. We could have John works at a particular company. We could have John knows Reshma. Reshma knows somebody else, works with somebody else, and you can develop a very complex graph. A lot of times you can read them and make sentences and infer understanding from it. Now, there's a couple different types of graphs. The one that I am probably most familiar with is property graphs, and those have internal structure that include properties, hence the name property graphs, and are very conducive to layers of abstraction. So John has properties age 27, weight 170 pounds. Like the relationship also has a property. There's a date that we collected this information, or maybe he actually ate his favorite ice cream, which happens to be mint at this point. So this is an example of a property graph. Now, there are also RDFs, a resource description framework is what that stands for, but it's an RDF graph. And those are very literal in their meaning, the semantics. And that is actually can be really good for inference, but also can make them verbose. So the graph I have shown at the top here, the property graph, that same graph is illustrated underneath the RDF. That's the same information, but you can see how it's very literal. But it can also get quite large and unwieldy as well. So I find that RDF I often think of is very machine friendly, and I think of property graphs as very human friendly. And so they have different, they can do just about anything in one versus the other, but they approach things from a different angle. Now, if you're interested in RDF versus label property graphs in more detail, I've included a link below of a really great talk with Jesus Barraza and Dave Beckberger. Both of them have lots of experience in both RDF and property graphs, discussing what the pros and cons and how you might choose one versus the other. I won't go into that here. That's a whole talk in and of itself. If you have trouble finding it on YouTube, you can also go to our GraphGeeks channel, which is just at GraphGeeks.org to find that. So when we think about graphs, as I said, it's any model of nodes and relationships. And we've got the models, which is the property graph and RDF are the most typical models. But you also have this dichotomy of graph database versus graph engine. So for a graph database, you're actually storing your graph so that you can answer questions, and kind of an ask and answer questions is typical use in a graph database. And there are a lot of benefits to that. And then a graph processing engine computes usually more complex analytics is often the reason why you might go for a processing engine, or you want to possibly layer. Now, you can take a graph processing engine and actually couple it with a graph database or a non-graph data store as well. So there's just different ways to handle the graph itself, whether you're storing it or whether you're just processing information and then dropping the graph, or using the results and then dropping the graph and not saving that. So different models for different uses. And then a knowledge graph. So what we're talking about today is a graph, and this is a very simple definition. It's an instance of domain-specific information that happens to be put together as a graph. And I often think of it as it's my company information, my product information, my customer information. So it's details about the relationships between things that my company or I care about. I could have a personal graph, and there are personal knowledge graphs out there, and the dependencies between them, and any rules about processing that information. So it's very specific to, you know, my enterprise, my interest, my research data, whatever that might be. So that's some basic definitions. And then the traditional knowledge graph uses, and this isn't use cases as much as, you know, technical uses, are on the left is more traditional. On the right, I would say, is more modern, but maybe not modern as in the last few months. But we have connected data overlay. So we all know we have data all over the place, right? And trying to figure out, you know, how do you integrate this information? You can use a graph as an overlay to look at those silos of information and try to see patterns and see duplications across different data sources. So almost using that metadata as a way to as an overlay and a visibility that brings all of your data elements together. And that kind of gets into the idea of a data catalog or general data management, classic traditional knowledge graph. You see it used to improve search. So you're adding semantics, which semantics just means meaning, but you're adding a human understandable meaning to your search. You get search results that are more contextually relevant. So they might be more relevant to the person searching, to the organization they're in, to you know, how they're actually phrasing or how you want to answer that information. So, for example, perhaps the logic you want to use is you know, about revenue and how you compute revenue inside of your enterprise. You want to have handled a very specific way, so you can add knowledge graph information and add some logic to that in how certain things are computed. It's also used for just human-friendly exploration. So I had mentioned, you know, property graphs can be very human-friendly. RDF can be human-friendly as well, especially if you add in some interfaces as well. But graphs can be a very friendly way to explore data, where you can have discovery that you didn't plan on. So serendipitous discovery, where you're just kind of looking around. A lot of researchers need to do that and have an iterative type of exploration. So those are very, I would say, traditional knowledge graph uses. And then you have probably a little more modern, but I would still say traditional knowledge graph would be to do things like make decisions. And so you, as a business owner, you might need to look at your supply chain holistically. So you want to look at not just one little element of your supply chain, but you want to bring in distribution centers and shipping capabilities. And you can look at the shipping routes as relationships between endpoints, and look at that holistically and help you with things like planning and optimization. It's a classic supply chain analysis and optimization. You might also be trying to improve predictions. So in the machine learning world, several years ago, people started using graphs and knowledge graphs to do feature engineering. So they would engineer features that would contain contextual information or statistics like PageRank. So I'm hoping everybody here knows that PageRank is, you know, one of the classic graph algorithms that quantify centrality or importance. And so if you can extract that out of your data, like what's the most important node, the most important person, the most important component in your product, that's valuable information to do machine learning on. And so that's a classic way to improve machine learning with graphs. And then also knowledge graph completion. So example, you looking at a knowledge graph, you rarely have all the information. There might be things that you didn't pick up in data collection, or things that might happen in the future. And that is using a graph to estimate links that don't exist is often termed as knowledge graph completion. So for example, you see this in drug repurposing, where you have drugs that are used for one case that have links to certain genetic capabilities, And then those are genetic signals, and those might be prominent in other diseases. And so you might be able to say, well, there might be a link. I might be able to complete the link between this drug and a new use case. And so knowledge graph completion is another way we try to use graphs for better predictions. And then I would say another one that I'm very interested right now in is advanced investigations. And that is kind of like the human friendly exploration, but a couple more layers of capabilities and robustness, where you're integrating algorithms into your search, so you have more of an interactive exploration. I put a few logos down here. These are all public, public companies that use graphs and have talked about their graph uses. I started just Googling. I wanted to put a few names that I thought everybody would recognize, and I could have filled this slide. So we see knowledge graph uses all over the place, a lot more than what I've listed here, but these are kind of the bare bones of like, what in general they're used for. So I'm going to pause and just see if there are any questions up to this point. So we talked about basics of graphs and what they might be used for. Rishma, I see there's a lot going on in chat, but I'm not seeing actual questions. So I'm going to keep going, assuming that we're all good. A lot of us hopefully have some basic graph analysis and background already. So let's talk about metrics and markets, because the title of this is Why Are Graphs Hot Right Now? So I want to convince you that graphs, and in particular knowledge graphs, are a really hot topic right now. First off, this you may have seen if you're into databases. This is DB Engines. They rank the popularity and popularity change of different database technologies. The green line at the top is graph database management systems. This goes back to 2013. And you can see just the excitement over graph databases over time has continued to increase. This alone should convince you that graphs are hot, but this is also looking at change. So it's so if you have a very traditional like relational database management system, the amount of increase isn't going to be as significant as something that maybe started off with less. So we know graph databases are hot. And so I turned to knowledge graph search trends in Google Analytics and said, okay, well, what do knowledge graphs look like? This actually, I think I pulled this from something that Rishma actually sent to me as we were prepping for the webinar. And this is from interest from 2004 in the US, looking at just search terms of knowledge graph. And I looked at that and then I said, okay, well, how about just the last 5 years worldwide? Kind of the same trend that we're seeing is just kind of up and to the right. Also taking a look at related search queries, LLM knowledge graph, RAG, ChatGPT, lang chain knowledge graph, which is an interesting topic, and of course GNNs. And I think that also, this is a little foreshadowing of what we'll talk about of like why so hot right now, that some of these related search queries are part of the reason. And then I took a look at, well, let's look at knowledge graphs versus graph databases, and looking at it over 5 years. So graph databases are in red, knowledge graphs are in blue, and you can see that they were tracking very closely. And then sometime, I believe that is, let me see, in the middle, that's probably around 2022, maybe halfway through, we start to see this divergence where knowledge graphs actually have more search trends and are gaining in popularity from graph databases themselves. So I had another slide that I had to pull the detail of, and I apologize, and I promise, coming soon on this one, on Graphy startups and investments. I'm seeing a lot of graph startups. Some of them don't talk about graphs. It's just graph under the hood, which is really fun and I think is a healthy sign. And then other ones that are restartups or startups that maybe spun off from another company and have recently got funding. I've also been talking to some different investors themselves that are very excited about knowledge graphs. And that's the first time in my career that I've had VC and investors actually say, we're not looking for a specific use case. We want knowledge graphs. And so I'm super excited about this, but I need to be careful in what I can and can't share. So I will share more detail, but I had to be a little more cautious today. But just know that there is investment coming, and there's a lot of Graphy startups, which I feel like is just super exciting. The other thing is, what's the market size? So I get to ask this all the time. And goodness, I mean, it really depends on how you want to define this. And so I've put links below of different estimates that are out there. And then I also looked at what I felt I was comfortable with, and talking to different companies where I felt it was a little more reasonable. The yellow at the top, or gold, that is, I feel like a bit high from my knowledge as far as like worldwide graph database knowledge. But that was estimated by Market Reports, or excuse me, Market and Markets. Graph databases now 2.9 billion US dollars, expanding in 2028 to 7.3 billion. I feel like that's a little high. Actually, I feel like that's high. And then there was some other research showing that knowledge graphs, so a subset of that, was at 0.9 billion now, in increasing to 2.4 billion. I feel like that's too low. And so it's really interesting, the overlap between the estimates of graph. At least I feel like there's an overlap between graph database market and knowledge graph market, in a way that probably 4 years ago we may have said knowledge graph market was a subset of the graph database market. I actually don't think that's true, because we also have non-database based sorry, it's funny to say, we have graph engine based knowledge graphs as well. And we also have knowledge graphs that don't actually, the knowledge graph itself isn't based on underlying graph model, which I don't agree that that's the best choice, but they exist out there. And so I feel like there's an interesting Venn diagram of overlap between these two. On the left in gray, I just added some other interesting data points that I found in some of this research. Like, North America is about a third of the graph database market. This is heavily software and services. 31% of services seemed a little high to me, but I have to remember that as people get new, or people that are new to knowledge graphs and enterprises, they still need a lot of assistance in getting off the ground. Graph analytics, you can see, is listed as higher than knowledge graphs, but less than graph database. So again, I guess maybe we've got another circle for a Venn diagram. So it can be a little confusing. If I were estimating, this is in blue, this is in my humble opinion, I feel like a more rational estimate for knowledge graphs is between 1 and 1.4 billion is what I would estimate that at. And then I would say that probably we're looking at, a little under 5 billion in 2028. So those are Amy estimates. I'm wrong all the time, but I feel like the truth is somewhere between the yellow and the gray above. So with that, I want to pause again, because I've just thrown like a lot of detail out and some definitions, and just see if there are any questions coming in. All right. So I'm just looking here. All right. I love this Peter comment. It's not a question, about participating in open source graph projects. Love that idea. The GraphGeeks team is also looking for open source projects. So if anybody has these projects and would like to talk about them at some point, just drop a note on the Discord. So before we move on to what's driving this interest, I probably do need to pause and make a comment about the definition of knowledge graph as well. So I gave you a very high level, domain specific information in a graph. But I do want to say that there are some definitions that are very aligned to having ontologies, which you can think of those as like schemas, and logic baked into the graph. If you use those types of definitions, sometimes the market size may seem smaller than more open definitions that don't strictly rely on strict ontologies and are a little more flexible. So the definitions, again, it all depends on definitions, but this is, I do have some questions on the Q&A channel. Thank you, Veronique. Sometimes it's hard to know where I'm looking. So actually, Veronique, since you brought this up, you're actually, this is a good question. I'm going to take your question first, which is, Veronique asks, what do you think explains the graph database curve to go down after 2022 in the database engine chart? And so that I believe that I will bring this as a trend later on as well. I believe that there is an interest in there's high interest in graph models, and there's a high interest in looking at our information in a graphy format. But graph databases bring their own challenges to maintenance, data modeling, and having experts that can actually maintain graph databases. So I believe the interest in graphs and graph models continues to increase, and in knowledge graphs, but the desire or the appetite to have a different type of database you have to own, manage, maintain is actually decreasing. So the desire for more simplicity. So that is my belief. You never really know what causes some of these, but that's my belief in that. And then let me look at this. So I'm going to look at another question. So it's a good time to pause here. This is from Luke Abbott. Do you know of any further details on the repurposed drugs using graph networks? Do you know the names of those clinical candidates that have come from that? So Luke, I am going to claim brain fog to forgetting the name, but I can see the website in my mind. So Luke, if you don't mind pinging me afterwards, I can send you some information on some open source projects that look at drug repurposing using a graph, and I believe they use Neo4j's Community Edition to do that. And then there's also some, I think, well-known companies that also look at that. I want to be careful about what's public and what's not. But yeah, definitely ping me at the end, Luke, and I will provide more information on that. All right. So we also have another question from Aaron Ortiz Mendoza. Thank you, Aaron. Has any use of graph network on biology modeling using AI? If I understand correctly, and Aaron, I might not be understanding this quite to your intent, but we do see network modeling of biology in healthcare in general and in research. There's a lot of genome sequencing as well that has used graphs, and whether it's combining it with AI. That's not something I've looked at lately, but I would be shocked if they're not including AI to pull out things like extracting important information and then putting it in a graph as well. So I'd be shocked, Aaron, if they weren't using AI and graphs together, because I know graphs in research and life sciences has got a long history. That shouldn't surprise anybody, because we all know that our biology and we are nothing but a set of networks and layers of networks, and everything's connected. So I actually find that the healthcare community and the life sciences community have a long history in the graph space and just network science in general. And then a question by Keith Murray. Are there some visual exploration tools for knowledge graphs that are popular to see the data? There are, and I probably should have included those in the resources, but there are companies like Linkurious, which is spelled with a K, Link Curious, if you will, that has a lot of visualizations to help see graphy data. There's another company called Kinaviz, which is spelled with a K, almost like KindViz. And they also have graph visualizations. There's another one called YWorks. There's Tom Sawyer. There's quite a few. If you look up graph visualizations, there's also quite a few open source tools as well that you can use. And there we go. And then we have a question from Luke that that I'm going to get to in a moment about machine learning and graphs. And so I will go ahead and move forward, and then we'll be pausing again for questions in a few moments. So, what is driving all of this interest? Why is it increasing now? So, first, Gen AI. It was really interesting when people started getting super excited about LLMs and Gen AI, and there was a little bit of hand wringing, I will say, in the knowledge graph community of, Gen AI is going to answer all the questions. Graphs won't be as necessary because knowledge graphs in particular have so often in the past been used to answer complex questions. You ask complex questions, you get the contextual relevance, you are looking over the different silos of your information. And if Gen AI can do all this, where knowledge graphs fit. That was like very early stage. That quickly went away, especially as Gen AI started to have some disappointment. And so I've got some, you guys can look up you folks can look up the different reports here. But the disappointment with Gen AI sinks into the trough of disillusionment. The Business Insider has some interesting notes from Goldman Sachs about the ROI on AI might be disappointing, and so I would say Gen AI in general at the moment skepticism is kind of settled in. I think that's due to considerable unexpected effort and cost to get some of these systems in production. Shouldn't have surprised any of us. Everything new takes a little while to become, something you can easily get into productions. But I think the excitement and these beautiful demos and announcements, I would say eye candy announcements, and then to not see things in production where people are talking about, hey, this is how I'm running my business, or this is how I'm able to do something amazing with my product. I think started to get the skepticism then. And then I think when seeing the shortcomings of not graphs, excuse me, of Gen AI in general, hallucinations, problems with measuring success, problems with explainability, inappropriate answers. It's really becoming kind of clear what those problems are. And those shortcomings are actually fueling interest in knowledge graphs because knowledge graphs are deterministic. So you put your data in a format and you're going to get the same results, the first time, the second time, the fourth time, and they're more explainable. And knowledge graphs are also more mature than Gen AI. And so you just have these many years in production with understanding, with people who have expertise in how you put these in production. And we're seeing knowledge graphs actually help with some of these Gen AI problems. And so it's very interesting. The concern a lot of the knowledge graph community had initially about Gen AI has actually been a boon for interest and kind of reinvigorating, I would say, possibly some of the funding that I'm seeing come into the area. Now, as I said, Gen AI is, moving into this trough of disillusionment while knowledge graphs actually have made it out. And so I can't share with you the details, but there is a really great overview of the Gartner hype cycle for AI that just came out, I want to say early this month. I may be off a few weeks, but there's a YouTube video down there. I think it's like 10 minutes. They just give you a nice highlight, but you can kind of see this where Gen AI is kind of sliding into that classic trough of disillusionment. At the bottom where people are unhappy, and what's really exciting is to see knowledge graphs are now seen in the slope of enlightenment, which is where you start to see really great predictable benefits and results across many companies. So I'm excited about this, but I think this is also part of what's driving the interest is we have a very respected analysts, Gartner, are talking about how it helps GenAI and talking about it in a more mature way as well. The other thing is RAG. So Retrieval-Augmented Generation. I'm assuming most of everybody here, have heard about this. Basically, a way to improve LLM performance. Usually will help improve performance and accuracy, reduce hallucinations, add more contextual understanding. It also allows people to make LLMs that are more adaptable or customizable to specific domains like my enterprise data or my industry that I care about. And also proprietary data. So it's a way to add in proprietary data that you don't want, out there in the world. Also has more different modes of capability or multimodal capabilities. There's been so much on RAG in general. I don't want to spend too much time on RAG, but I will say there were over 340 papers from January of this year to June of this year. I tried to find updated information. If somebody knows what the updated number is, let me know. But there's so much I gave up trying to actually synthesize, and I found a smart search app. So this is at the bottom here. Check it out. That is on Epsila for searching RAG papers. I'm like, whoo, fine, so I can actually ask questions and get things from the research without trying to read 300 plus papers. So I have a linked, actually it's a LinkedIn link here at the bottom, but you can also search RAG search Epsila or go on the Epsila site and search for that. So I would say definitely take a look at that. And then there was also a really great blog by Ben Lareka and Prashant Rao on their recommendations and their experience using RAG and knowledge graphs together, some of the challenges they had. They provide some really nice guidelines. So there's a ton of, obviously there's over 300 papers, but these two I thought was a really nice start to just kind of get your hands dirty and play around with that. Now with that, I did want to say, well, what's the difference between, regular RAG and graph RAG? So if you're thinking about standard RAG, is that you're usually looking at embeddings and vector databases to look at similarities of material. Graph RAG is using the graph structures, not necessarily relying on embeddings. And so one of the things that's interesting about graphs in general, if I didn't say it before, is that you're capturing not just relationships, but the structure of those relationships. So if you would imagine a hub and spoke network, which is like classic in transportations, and where you have like one hub and then you've got nodes that hang off of those, that structure actually has meaning. If you see a financial network with islands of floating transaction, that's often criminal activity, and that's a good sign of or bad sign, I guess, of money laundering. And so shape has meaning, and you get that with graphs, and you get that with graph RAG, which for me is kind of exciting, and it adds a different component to your predictions. Now, standard RAG also focuses on similarity scores for kind of individual elements, individual sentences. And graph RAG has a tendency to give you a larger understanding of relationships between elements, between nodes or entities. Standard RAG is definitely simpler to implement. And I understand is faster for retrieval, although I suspect that that's probably changing all the time. Graph RAG has a tendency to be a little more complex because you are starting with a knowledge graph as opposed to a flat file, and then you also have to maintain your knowledge graph. Standard RAG definitely suitable for like quick general Q&A. Straightforward, and with graph RAG, if you have more complex scenarios where you want that structural information and contextual information is just really important. So those are kind of the highlights of what's the difference between one versus the other. Again, lots of information out there, and I am definitely recommending to Data Umbrella that you do a whole session just on this because you can just go really, really deep here on that topic. I will say the results using graph RAG, and this is again driving popularity, is we've seen lots of examples. We've got an example here is a paper from LinkedIn talking about cutting customer support resolution time by almost 30%. That's huge. And then we have Juan Cicada and Alaman updated some previous work they did. So they did some work last year looking at the benefit of using GraphRag and how you can improve your predictions there. And then they just recently updated that, looking at reducing error rates by 20%. So a link to that paper, which is an excellent paper as well. But the part of this is you still need to build a knowledge graph, and that can be a challenge. We do have a challenge with garbage in, garbage out. So if you don't build your knowledge graph well, if you aren't thinking about really good knowledge management practices, a lot of times the results you get are you're not going to be happy with. And then the need to have better metrics as well. Is like, how do you actually understand the metrics, not just some arbitrary data element that you're just looking at test data. I believe we need to start looking at downstream applications as well, and looking at the results in some downstream applications, very similar to what LinkedIn did. And then, of course, you have your continual care and feeding of your graph as well. There is a book coming out that I want to call out. So Tomas Bratanek and Oscar Hain have a book that is in early stages with Manning called Knowledge Graph Enhanced RAG. Link there where you can start taking a look at that as well. So we're still talking about like these things driving interest in knowledge graphs and why we're seeing that go up. Another Gartner is we're just getting more attention from Gartner and more and analysts in general on the importance of knowledge graphs. So Gartner recently published a list of 30 emerging technologies. They identify this as critical for product leaders to evaluate as part of their strategy, their competitive strategy. Knowledge graphs in GenAI are things you should be looking at for impact now. It's very exciting to see, knowledge graph in the same space as, GenAI. And as you can see up and to the right, it is listed as a critical enabler and something that will have a high impact. And so I believe these, things like this are also, driving interest in knowledge graphs. One more Gartner element is at the Gartner Data and Analytics in London earlier this year. They listed adding semantic data, semantic data, as one of the top trends in data integrations in engineering, and a way to kind of add in, complex relational data and having things be more contextually understandable and contextually appropriate. So it's things like this that are kind of really driving a lot of excitement in knowledge graphs, and it's just wonderful for those of us who've spent over a decade or our entire career focused on this area to kind of see this excitement and interest. So I'm going to pause again, and I will look at the Q&A before we get to what's next, which is coming up here. We've got some questions on visuals. So from Peter, how do you actually get started with graph analytics? When coming from analyzing data from relational databases, how do you convert the data to create the relationships from already existing database? So I would say I would definitely take a look at some of the community editions of some of the more well-known tools out there. There are many of them. Having worked at Neo4j, I know they have a very robust community edition, but you can definitely I will definitely say one of the challenges is getting your data into a graph. So I would definitely suggest taking a look at some of the tutorials and look at some of the tools that people are using. And in particular, there's some really wonderful postings on building, and I'll give you a link here in a moment, on building a knowledge graph using some AI and LLM tools as well. So there's some interesting tools out there that will help, but having a basic understanding of graphs and graph data and how you can go wrong in modeling your data is also just it will pay dividends if you spend a little bit of time looking at some of the tutorials as well. All right, and then I have another question from Titus here. Titus Correz. I hope I'm saying your last name correctly. Safe to say knowledge graphs help overcome LLM limitations. You pose it as a question, but it sounds like a statement. So I will say yes, but there are challenges, as I said, and there's a lot of good material. I think we're going to be talking about graph RAG and knowledge graphs and LLMs for quite some time. But we're just getting started, so there's definitely a lot of area to go. And let's see, another questions from Kasaba. I hope again I'm not mispronouncing your name. How would it be possible to use graphs for RAG if there's no similarity score or embedding? So I do believe you can use graphs for RAGs with other types of scoring. And you can also infer, similarity metrics from graphs as well. So you can do similarity metrics using graphs. So there are algorithms that will compute similarity based on elements, either things like properties, or you could do scores that are similar, but it's not a classic similarity score. So there are definitely ways to do that. And I would definitely recommend looking at, in particular, Tomas's book on graph RAG and knowledge graphs, because he will definitely go into more detail on that. All right, so I think I've gotten to most of the Q&A, and there'll be time. So we have just a few slides left. There'll be time for more. So what's next? So we know knowledge graphs are hot. We know they have been benefiting lots of companies for a long time. They have, there are obviously some challenges, but what are we going to be talking about here in the near future? First thing, and maybe this answers some other questions as well, is there are still challenges. So there's a lot of knowledge graph challenges that have existed for a long time, that people have worked through or are working through. And we still have some of those to address, and we have some new ones. The red graph RAG element is a little bit new, but it's based on a lot of issues that we've had with knowledge graphs in the past. So I do believe we're going to go through a little bit of disappointment. If Gartner were to break out graph RAG on its own, I would say it's about to go into the trough of disillusionment, and then it'll come out. Again, I mentioned the garbage in, garbage out, productization, maintenance, a little more effort to tune it and get it in production than what people might expect. But I believe that there are examples of people working through some of that. My one big concern actually with graph RAG and the potential disappointment is if people aren't patient to work through the problems, and if us as a graph community don't help work through those problems, we could have a disappointment with knowledge graphs in general, where people, throw up their hands and say, we've tried it, it didn't work, we're going to move on to something else, as opposed to working on some of the very specific problems with graph RAG. So I think that if you are working with it, work through it. There's a lot of people working on the underlying issues that are there, and they're still seeing, net positive, low-hanging fruit. And there's just more to do. I would say lack of expertise in knowledge graphs are still a challenge. So if you're interested in knowledge graphs, pick up some books, follow webinars. There's just a lot of material, and it is a beautiful, wonderful space to be involved in and to see the relationships between things. So graph experience, and when I talk about expertise, there are different types of graphs, kind of like what we talked about in the beginning. So understanding graph analytics versus graph queries versus knowledge graphs versus different types of graphs. It's just a very rich space. I would say domain expertise as well. And so one of the challenges I think with knowledge graphs, and I think maybe with AI in general is the assumption that you don't need domain expertise, but you still do. You absolutely need people who understand your industry, who understand your patients, your customers, people who understand shipping. You know, you can't AI your way out of it. You can't knowledge graph your way out of domain expertise. And then I would also say lack of expertise in building schemas and ontology. There are whole careers focused on being an ontologist, on building knowledge. And so it's a discipline that even if you're not an expert in, you should respect and pull in expertise when you need it. And then I mentioned the Dunning-Kruger effect, which is just kind of everyone can Google that if they want, but I would say just knowing that that there are experts out there, and some of this goes very deep, and kind of understanding when to pull in people with different expertise. Also, I would say quality measures. So that's something in knowledge graphs that I would like to see more filled out, or have more ways to measure the quality of our knowledge graph. It's not an easy thing to do. I think that's an interesting area, especially as we think about AI enabling knowledge graphs. Graph modeling, again, needs expertise. So we'll go back to the expertise, but there's a lot of choices when you do graph modeling, and a lot of times it can be specific to your use and even your question. And so being able to experiment and getting into graph modeling can be a challenge. There's a lot of examples out there. Definitely take a look at it. And then the last one is knowledge graph kind of suffer a little bit from not being fluid enough. And what I mean by that is the data itself, lack of interoperability, getting your data into a graph and out of a graph needs to be more automated. There are some startups that are tackling this. There's a lot of things that different companies are doing to try to plug in to other data sources, even data sources you wouldn't normally think about as Graphy, like Snowflake data, BigQuery data, Spark data, and transferring in and out. Transforms can be a little onerous. So again, there's some really interesting companies that are looking at how do you more fluidly transform data and blend data as well. So I'm very excited about probably the right side of this, in just there's technologies that are being developed to help with these challenges, but they are challenges that we're going to be talking about, I think, for the next year. And then one of my more interesting predictions. So I'm going to make a prediction that the themes for the next 6 months, or in 6 months, what are the 3 things we're going to be talking about when it comes to knowledge graphs? We're going to be talking about graph RAG and building knowledge graphs, and we're going to be talking about them becoming more practical. So I would imagine things like, what's the practical workflow for constructing a knowledge graph from unstructured data? Really great talk from Paco Nathan a couple weeks ago, or 2 weeks ago, or last week. I can't even remember anymore. But anyhow, it was just recently. He's definitely going to be putting out more material. Really a good person to follow. But I think we're going to be that's going to be an example of what we're seeing is like, hey, how do you actually make this work in practice? How do I make this work so that I don't have the garbage in, garbage out data? How do I use other tools together? We're also just recently, I think it was August. So this month, there was a paper with several NVIDIA authors on hybrid RAG, integrating knowledge graphs and vectors. So why not combine them both? And I think that was a very practical approach. And so I'm interested in that. So I think we're going to be seeing a lot of that in 6 months. I think we're going to be talking more about graph as an enabler for knowledge. Pardon me. More talking about AI as an enabler to knowledge graphs, which kind of goes a little bit with, theme number 1 as well, where as opposed to saying, how does knowledge graph make GenAI better, we're going to be talking about different AI and GenAI and LLMs to make knowledge graphs better, and talking about classic knowledge graph use cases that get really, really interesting and really mature. And that kind of hits to my third prediction, that in 6 months, we're going to be hearing the term graph BI more, and it's going to really enter the stage. So there's There's a couple companies kind of doing a little bit in this space now and talking about this now. They may not be using this term, but we're seeing improved natural interfaces with graphs, better visualization to some of the questions on that. We're starting to see the blending of classic knowledge graph capabilities, visualization, and analytics and algorithms together, and BI-like capabilities as well. And so this one I'm super excited about because as somebody who is awful at doing code, but has a lot of great ideas, I think, that I want to explore, having something that I can do it in a Tableau-like format, that I can do it in a dashboard-like format, that I can add in non-graphy and graphy data gets me very excited. So those are my 3 predictions for 6 months from now. There's one gray item here at the bottom with a question mark. I've heard some people talk about knowledge graphs as reinvigorating expert systems because you can add in explainable logic and you can update rules, and the arrows can act as functions. The relationships can be computing elements. I'm excited by that idea. I haven't seen anybody do that in production yet, or at least that they're talking about. So I'm not sure. I wouldn't put it on the next 6 months, but I'm hopeful for that in the future. And hopefully, I'm wrong. That 6 months we're talking about that as well. But those are my 3 predictions for 6 months from now. And then I have, I think, one more slide here on undercurrents to watch. And I realize that we're getting short on time, so I will make sure to share these. But the undercurrents to watch. So these are things that I feel like are changing the knowledge graph space. Graph frameworks are changing a lot. Databases versus engines, RDF plus property graph stacks used together. Yes, there's examples of that. I know of one company doing that at an enterprise level. Super exciting. We're seeing big and small graphs mixed together, and also more small graphs. Getting unstructured data more into a graph so we can look at unstructured data as a graph. So there are companies working on that, plus adding relational data as well. So that area is really exciting. Query languages, especially with LLMs, are kind of moving down. So kind of lower in our stack. We see people mixing declarative and procedural, so that's interesting. AI and graphs, we've talked a lot about that. One element I haven't mentioned is causal graphs. If you're not aware of that, we can do another talk on that another time, but that's where you're using the arrow of the graph to understand how A might cause B, and then are able to do what-if analysis as well. So that's a super exciting area. Graph BI, I just talked about that and why I'm excited about that. And then more advanced graphy stuff in the future that I'm always watching, but it's probably more future. There's a lot more temporal and geospatial in graphs that is very exciting to see. Higher dimensional graphs, so HD graph is a term that if you're not familiar with, I think we'll be talking about that in a couple of years. And neuromorphic computing and graphs as well are a natural fit because they use neural networks for computing, and you have more of a graphy format. So those are, I'll wrap it up now. So definitely reach out to me if you have questions, want to talk further about graphs. I love this space and knowledge graphs. GraphGeeks is a vendor neutral graph community. Discord link here, YouTube there. Join us. It's a lot of fun, and we love talking about graphs. So with that, I'm going to take a breath and ask if I'll take a look at what's left with questions, but also ask Reshma if there was anything that came up while I was going through slides.
Hi, Amy. Beryl here. I'm going to read some questions that are on the Q&A chat, and then you can respond to them. So Kate asks, can you talk a bit about what goes into longer-term maintenance of a graph database and pitfalls that make it harder to sustain long-term uses of graphs in a production pipeline?
Yeah, I would say a couple of the things that go into it is, depending on what model you're choosing, you can have a model that is more strict up front. So you have a strict schema or script ontology, which definitely keeps people from adding in data elements that shouldn't be there, that you don't want there. But it also can make it more onerous to keep up to date. So for example, if you have a very strict ontology and then you acquire another company that doesn't use those terminologies, you then have to deal with that. So that can be an issue. But also at the same time, you may want it strict because maybe you have regulation, that you need to do. So those are some areas. The other, I would say, parallel to that, the other thing is just the data model itself. A lot of times how you model your data in a graph, because graphs operate and compute differently than flat data, you can tune that for very specific uses and get really great responses and very specific questions. But then when another organization in your company, or you want to expand the use, that data model may need to change. And so those are probably, I would say, maintenance of the data model and your schema ontology are probably some of the biggest challenges in long-term maintenance.
Okay, another question. So Stephen asks, for adding some KG lessons to a university course, do you have suggestions for textbooks one can use?
Yeah, and we can definitely share more of that later. So I would say there's Neo4j has put out some really good books on knowledge graphs in particular. Jesus Barraza was one of the writers on that, and I feel like that's a very solid introduction to knowledge graphs with some very specific. I would probably start with that one. And then there's also some books in Manning, as I had mentioned, especially if you want to branch off into the machine learning and GraphRag and knowledge graphs as well. So those would be my starts. But if you want to ping me later, I have a list of like 20 books that I love on graphs and knowledge graphs.
Next question is, what percentage of companies use knowledge graphs for their operations or hire outside vendors for KGs? Are small private companies? Any idea?
I do not know the numbers on that. It's difficult to get numbers. I will say, if you believe some of the analyst numbers, you'll hear things like 80% of enterprise companies will be using graphs or knowledge graphs in 2030, I think is some of the numbers. But as far as like how many are doing it today, I think it's much more extensive than we realize, because we have vendor numbers, which I talked about, but you have a lot of people that build their own. And so you can build a knowledge graph with open source products. You can build it with your own tools, and in those cases, we just never see them. So I don't have good numbers on that, but I will take that challenge to try to make an estimate for the next time we talk.
Okay. Next question: What's the role of knowledge graphs in making use of LLMs more reliable ethically?
Ethically, that's a really good. That's an interesting to add that bit on there, because I do think that with knowledge graphs, because they are deterministics, and you can follow the arrows, if you will, you can follow the links, that they are by their nature more explainable than other types of probabilistic estimation. And so if you have a prediction, I don't believe that we will have LLMs that are only improved by knowledge graphs. You're going to have this mix, but we can use knowledge graphs to help add in more explainability, and we can use knowledge graphs also, especially if we add in rules and guardrails, that we can use it to say, hey, you can't. It's impossible for. So, for example, you could use a knowledge graph to say it's. The arrow only goes from mother to daughter. It's impossible to have a daughter have birth a mother. Like, that's an impossible rule. And you can add that to your knowledge graph to kind of put in guardrails. So I think it does have a role, and I think explainability is a big one. And then the other one I would say is just guardrails as well.
The other question is, does there exist any benchmarks for graph databases?
Yes, there is quite a few benchmarks. If you're looking for purely performance, you want I'm going to just type this in, LBDC. benchmarks. Here we go. I'm putting it in the chat. And they have a lot of different, various different types of benchmarks that are more performance. And then if you're looking for, accuracy, that's where, I was talking about, I'd like to see more measures and more automated measures. There's a lot of research on that, but not as much, in the way of like what you might think of as classic benchmarks. I will say some of the benchmarks do tend to be a little academic in their approach. And so you may still find that there is a better approach, even or a good approach for what you want to do, even if it's not like the number one, in the benchmark, because you have messy real world data to deal with.
Okay, our last question is, and I think you've already tackled this, what are the best resources to learn about knowledge graphs and graph databases?
Yeah. So I hope I've addressed that. Well, I will say, join GraphGeeks. We are a community of people just like to help people where they're at. And you can definitely ask that question, because I have a list of books that I really enjoy, that I feel like are strong. And I already mentioned a couple on knowledge graphs. If you like graph algorithms, I actually wrote a book on graph algorithms. It's an O'Reilly book. There's a ton of really great material on network science as well, which overlaps with that. And like I said, there's a wealth of information out there, but I would definitely start with some of those. And I will say, shout out to Neo4j for just really good classes as well. So they have some online tutorials that are really quite excellent.
Okay, thank you so much. There's some good comments there on the chat. Great presentation. Thanks for the great information. Really interesting topic and technology to use in the future and now. Thanks for the presentation. Reshma, thanks for the organizing efforts. Amy, thanks for your presentation. Excellent, clear presentation. You're really good. Thank you. Kate says, thank you. The things to be mindful of with long-term maintenance is great to be aware of, and the presentation gave me a ton to start looking into. Yeah, so
well, wonderful. Thank you, everybody. Yeah.
Thank you so much, everyone, for joining. Thank you so much, Amy, for the presentation. As said before, we're going to have this presentation up in the next 24 to 48 hours. All the resources that Amy has mentioned will be provided and will be attached in the video description, and more links that she has talked about if they are not in the slides. The slides will also be shared as part of the video presentation so that you can take a look at them and go through them later. Thank you so much for joining. Amy, thank you so much for your presentation. We're looking forward to hosting you again to learn more about knowledge graphs.
Thank you. Thank you, everybody.